Right. So in this video, we're going to talk about the call setup and tear down process. Now, obviously, in order to troubleshoot a telephony network, you need to understand the process of as the call being set up and what happens when the call hangs up, so that you have a better understanding about how to troubleshoot the network. And with the detailed understanding about the both process, you will be able to identify when you're analyzing the packet as what's happening during each process, such as are we receiving what we expected as part of our standing procedures. So call setup, which initiating a call. So obviously a user will has lifted the handset, receive a dial tone. And that dial tone is coming from the call manager server or CUCM. They will dial the call party's number. So in this case, for example, 1000 is dialing 2001. So the intention is to call that particular person right about there. These digits will be sent to the call control agent, in this case, this call manager, one at a time, depending on the type of phone that you're using. We will talk about the this numbering concept later in the course, but right now understand that the digit will be sent to the call control agent, CUCM, which could be a voice-enabled router or could be a CUCM manager. Now, once that part is done, your next step is for endpoint discovery. The call control agent, which is the call manager right here, will then needs to identify the location of the number that you dial. In this case, the called party. This endpoint could be registered locally to this call manager X, or could be registered remotely to call manager Y. So you need to understand where the call manager needs to understand where is this device located. It might be require a routing configuration to route the call to a remote destination. So once it identifies that, your next step is to permission check. So call manager is going to say, hey, does this guy have the permission? The permission check may be performed to confirm the calling party, in this case, this particular phone, has the right to dial that number. So that is one of the things that will happen before even signal is sent to the remote site. So once the permission check is done, then comes to bandwidth check. Because remember, we could use call admission control to restrict the bandwidth, or your network may not have enough necessarily bandwidth. So in this scenario, during the bandwidth check, the call control agent, in this case, call manager, may check to determine if there is enough sufficient bandwidth on the network to even allow the call. The bandwidth check is better known as call admission control. So this call admission control, for example, is going to be part of your administration configuration, and you want to make sure that you have a proper understanding about that. Now, bandwidth check is better known as, bandwidth check could be call admission control, or it could be RSVP. So providing that these two information has been successful, then the call progress tone steps take place. In this case, once the call party endpoint is ringing, this case, 2000 phone is ringing, then a progress tone has to be sent back to the caller, right? So this guy knows that the call is in progress. Otherwise, people would assume that there is something wrong in the network. If the call party is engaged, the engaged progress tone will be played back, which is another word, busy tone. So there are two examples of call progress tone that are available during this process. Now, once the call has been answered, once the call party answered the call, the progress tones are no longer needed. A CDR in this once you answer the call, at that moment, the call control agent, the CUCM, can be configured to log all call information. Logging can be done through several different technologies, such as syslog server, radius server, or direct database entry. The method used for logging will largely depend on the type of call control agent that you're using. For example, if you are using call manager, CUCM, in this case, logging can be done directly into the database. Whereas if you're using Cisco router as a call control device, such as Call Manager Express or CUCME, in that case, syslog or radius server can be configured to achieve that. Now, once the call detail recording takes place, then we do capability negotiation. This is where the codec negotiation happens. The capability negotiation exchange is required in order to find a common, supported, and requested codec between the two endpoints. Both party has to agree to the same codec. Both party has to agree to all the byte size and all the other necessary capabilities. If for some reason one of the negotiation has failed, chances are that either the call will fail or you may need an additional device to make that call work. Think about in a scenario where you and I are speaking different language. So let's say you speak English, I'm speaking Hindi or Indian, a different language. Obviously, we may not understand each other unless we either speak the same language, in this case English, or we need an interpreter. So capability negotiation will identify those shortfalls and substitute whatever can based on what is configured to either include an interpreter, in this case transcoder, or could we just simply say, I can't negotiate, so therefore I'm going to send you fast busy signal, which will basically indicate the call has failed. Now, once the call negotiation is done, then in negotiating the stream, the two endpoint, in this case, the two phone, will then negotiate the port that they want to be used to establish a bidirectional connection for real-time transport protocol, or known as RTP, and as well as RTCP. RTP is the protocol that carries the conversation. So if I say hello world, it's going to carry that conversation into that packet. But it uses a port number, UDP port. So it will have to negotiate from this range, what port do you guys want to use to transport the packet? At the same time, it's going to negotiate an RTCP. So RTCP, or real-time transport control protocol, is basically will use the RTP port +1 to pair the connection, which is used for monitoring the quality of the RTP or monitoring the behavior of the RTP protocol. So what RTCP does, it monitors the RTP flow and kind of send a feedback to the calling party, say, look, I am experiencing problem in the network. There's a jitter, there's a packet loss, something is happening. So the quality of the call or RTP flow will be reported back to the caller or calling party. So that in order to do that, is going to know which RTP flow to monitor, right? Because there could be 100 of RTP flow. Well, if your RTP use port number 16384, let's say 16384, in that case, RTCP will be using 16384 +1. So RTP, if it is odd number or even number, doesn't matter, is always going to use whatever the RTP flow +1 to indicate that that is flow monitoring that particular RTP session by simply subtracting that. So if you are looking at an RTCP port 16385, that means that is for RTP 16384. So that's an easy way to figure this out. Now, once you're finished talking, you're ready to hang up the call, you simply then hang up. So when either calling or call party terminates the call by hanging up the endpoint, a signal is sent to the call manager, in this case, call control agent, to tear down the call and release the resources, such as memory and all other stuff. Close connection, a signaling between the call control agent, it will be sent to notify and acknowledge the termination of the call and release the resource. Then it goes back to CDR. CDR will record the call as call being completed. Bandwidth will be released so that it can be allocated for all other calls. So these are the steps that take place as the call is in progress. And it is our job as an engineer to have a good understanding of that so that we know exactly where the call could fail and why the call may have failed. So that is an example of the call flow of your IP telephony. This is an example of a SIP call flow. Now I'm going to walk you through step by step what happened when an initiating party initiates a call. So endpoint, such as, let's say I am the endpoint, I'm going to pick up the call to call you. So I initiate the call. I will be known as user agent client, or UAC, and I will be sending an invite message to my user agent server, in this case, the call manager. So the user is called, sorry, let me rewrite it. User is called UAC, and this guy, call manager, will be called UAS, user agent server. And I'll be sending an invite message. Now, in this case, the user agent server, call manager, receives the response to the invite message using 100. So it's going to use step number one, initiate the call. Signal is sent. It's going to receive an acknowledgement with 100 trying messages. Now, the terminating gateway sends a signal to the recipient's telephone. In this case, it's going to send a signal to this phone that, hey, you are receiving a call. Step number 5, the recipient user agent server informs the user agent client that about ringing signals with 180. So, which is again, this guy sending a signal back to saying, hey, call is taking place. So now both sides are receiving the ringing. Step number 6, where originating gateway sends the ringback tone to the caller. So this guy will send a ringback saying, hey, the call is in progress right now. Step number 7, the called telephone is taken off the hook. So now, after all the ringing and everything, whatnot, this guy decided to answer the call. So he picked up the handset, right? So the call party is taken off the hook in step number 7. Step number 8, if the user agent server, this particular call manager, UAS, okay, step number 8, the user agent server of the recipient, this party, determine that the call parameters are acceptable in all the negotiation and everything. It responds positively to the user agent client, which is this call manager, saying, okay, everything is okay. So it will send an acknowledgement in step number 9. Okay. Step number 9, originating UAC will then issue an acknowledgement. So step number 9, this call manager sending an acknowledgement saying, okay, I received your information. Now, step number 10, at this point, the user agent client and user agent server have all the information that is required to establish an RTP stream. So they're going to negotiate the port number, RTCP port number, whatnot between them. Step number 11, one of the party decided that, okay, I'm going to hang up the call. It sent a buy message to the user agent. So let's say if this guy hang up the call, he send a buy message to this guy. This guy will send a buy message to this guy, or vice versa, doesn't matter. The buy message is confirmed by acknowledging 200 okay, that yeah, I received your buy message, we're all good to go, have a nice day. So it's kind of like a complete the call. SIP will use other standard-based protocol to provide large set of features based on relatively simple mechanism. And we're going to talk about what is that mechanism. It's called Session Discovery Protocol, SDP. Session Discovery Protocol is an IETF-based format for describing streaming media initialization parameter in an ASCII string. SDP is intended for describing the media communication session for the purpose of session announcement, session invitation, parameter negotiation. All these are part of session description protocol, or SDP. SDP does not deliver media itself, but it is used for negotiation between the endpoint of media type, media format, and all associated properties. setup properties, and parameters are often called the session profile. SDP is extensible to support new media type and format. Now, this figure will show you there are two SDPs example. The table explains the parameter, what they are used for. So if you take a look at the first one, example number 1 is an audio call. How do I know? Well, look at the media. M is equal media type, and it's an audio media, right? So obviously that's an audio call. It also tells you what is the RTP port number, and also tells you various other things, like for example, what codec is going to use. So if you take a look at carefully, you'll see RTP 49109, and this 0 that you see right there, that's an indication it is G.711. If it is other than 0, it could mean something else. Okay. If you take a look at example number 2, it's also an audio call. If it was a video, it'll show you video. It is using the port number, plus it has offered 3 different codec: G.729, which is 18, G.711, which is 0, and G.711A law, which is 8. So you got three choices are made: G.729, 18, 0 is G.711, A law, mu law, which is North America, and G.711 A law, which is the third choice, 8. So by looking at this number, you can automatically know what codec was offered. So it is important that you understand these values so that when you're troubleshooting your SIP, you're going to see this stuff. So let's go through these items, what they basically does. V stands for version. So V equals 0. That's the default version. Then you'll see O. O stands for origin. Origin means username, session ID, version, network type, and address itself. It contains multiple information in the origin. Then you got S, session name. What is the name of the session? It could be your username. Who knows? Time. T stands for time. Start time and the stop time. Okay. C stands for connection data. Okay. Connection data means what IP address it was used to establish the connection. So here you find the IP address and what type of IP protocol. Is it IPv4 or IPv6? And then you got M stands for media. Okay, it will get media, the port, the transport, and the connection address where it's connecting to. Audio means the codec it will offer. 0 equals G.711 mu law, which is for North America, Canada, US, and Japan maybe. And you got 8 G.711 A law. 3 is GSM codec, and 18 is your G.729. These are your information that can help you troubleshoot or identify the problem as we go through this course. So make sure you are familiar with them. Make sure you can read what that's supposed to mean. Because if your job involves in analyzing the trace files, you'll see lots of this stuff, and it may help you or may be required for you to understand those log files by reading through this information to give you an idea what you're dealing with. Now, one of the things about SDP is that how am I going to offer this as SDP to you? If I'm calling you, how am I going to offer this to you, right? So there are 2 ways to exchange the SDP offer and answer messages. Now, these methods are commonly known as delay offer and early offer. And it supports for both method by user agent and client server is a mandatory. So it's important that both device supports that. In simplest term, the initial SIP invite, that if I'm calling you, my SIP invite to you is the initial. The initial SIP invite that is sent with the SDP in the message body will define as early offer. That means if I am sending an invite message to you, and I'm also sending the SDP at the same time, that is called early offer. I made the offer to you very early stage, right? Whereas if I send the invite message, then I wait for like 150 seconds or whatever to see if you are going to send me something. If you don't, Then I'm going to offer you my SDP or my negotiation parameters. That is called delay offer because I delayed it. So remember that. If I send an invite and SDP together, I am giving you all the, I'm telling you what the SDP is going to be. I'm not waiting for you to send me anything. But if I wait for you to send me anything, that will be called delay offer. Delay offer is illustrated below. In delay offer, the session initiator does not send its capability. As you can see, invite is sent. There is no SDP until somewhere right about in middle is step number 8 and 9. So that is delay because the calling party waited X amount of time. So delay offer will wait, calling party will wait for the call device to send its capability first, list of codec, or whether it's an audio call or a video call. Now, delay offer is recommended for SIP trunk because it enables ITSP, service provider, to provide their capability first so that you as a customer can negotiate properly. Because obviously, sometimes we don't have the power over service provider to decide what codec or what to offer. So we've got to wait for them to negotiate with us. Call manager will allow administrator to select which offer you want to use. Cisco Gateway supports both methods, but originating gateway by default is set to early offer. Call manager SIP trunk by default set to delay offer. Now, early offer, which is illustrated as you can see, that is SIP invite and SDP happens on step number 1 and 2. So right away. So therefore, all the capability is negotiated by send originating party. Okay, in this case, I get to dictate what you want to negotiate. And early offer is enabled by default on a voice gateway. I'm talking about Cisco router acting as an originating gateway. But when you're establishing a Cisco SIP trunk from call manager or CUCM to any other device, that SIP trunk by default will have early offer as a delay offer enabled. So let me go show you how to configure a SIP trunk that enables delay offer or early offer for you. So we're going to go to our lab. We're going to log into our call manager. So I'm going to create a SIP trunk. And first, I'm going to show you how to enable delay offer. So I'm going to go device, trunk. I'm going to add a trunk. This is basically just a demo trunk, not going to work. I'm going to say SIP. Protocol is going to be SIP. Next. And I'm going to call this demo SIP trunk. Put a device pool. Now, if see this option right here, media termination point required. If that is unchecked, then most likely you have delay offer. Now, when I say most likely, it's because this also depends on your profile. So below, at the very bottom, you'll see there's something called SIP profile right there. That SIP profile can also have delay offer and early offer enabled. So that's why I say maybe. But if I check this, it's going to guarantee it's going to use early offer every time a call passes through this trunk. That is a must. Okay. Whether even if the call needs an early offer or not. Okay. So every call that even does not need early offer capability will use early offer. So what happens if you want to say no? I want a solution that enable early offer only if the call needs it. Otherwise, use delay offer. So I'm going to keep that unchecked for that. But to enable that feature, first thing I got to do is I got to go back and create a SIP profile. So I'm going to go to SIP profile. And I'm going to copy this SIP profile called VBC, standard SIP profile VBC. And when I'm there, you'll see that there is an option here on this profile. Right there. Already offers support for voice and video call. It's disabled by default. I want to say best effort, do not insert MTP. Mandatory, insert MTP, which is media termination point, only if needed. So I'm going to basically specify a profile that says use media termination point for early offer only if it is needed. So I'm going to save that. And I'm going to go back to the trunk. Let's call this SIP trunk again. I didn't save it. I'm going to call this demo SIP trunk Toronto. And all you have to do at the very bottom, you will see called SIP profile. I'm going to select the BBC and save. And that's how you enable early offer and delay offer. So again, this is not something that hasn't been will going to work because that's just a demo environment. So as you can see, this is basically the difference between them, both early offer and delay offer. Hopefully you got an idea about what SIP is, how signaling works, the type of different signaling, the differences between early offer, delay offer, analyzing the SIP packets, SDP. You need to understand what those letters mean so that you can easily troubleshoot, and hopefully got understanding the process of call being initiated and what stage it goes through. So thank you for watching this video, and I will see you in the